All right, so section 6.1, we've been looking at all of those exponent rules, kind of brushing up on all the ways we can simplify things with exponents. Now we're going to start looking at roots. So our objective today is to be able to find nth roots. You've probably done a lot of work with square roots, maybe even some with cube roots, but you may not have taken higher powered roots. Okay? The one thing that makes this section more difficult is there are several little kind of picky details that you have to pay attention to. The questions aren't long and complicated, but we do have to kind of watch for those picky details. Okay? First thing it says, corresponding to every power there is a root. For example, just as there are squares or second powers, there are square roots. So in this first line, it says 5 squared is 25. We could turn that around and say then 5 is the square root of 25. Okay, it's the number that was raised to the power to make 25. So in this next one, we have 5 cubed is 125. What would we say to turn that around? 5 is the cube root of 125. Here 5 is the fourth root of 625. Okay, does that make sense? We have a formal definition for our nth root. This is one of those details that I said you kind of have to pay attention to. The first line says, if a to the nth power equals b, with a and b being real numbers and n is a positive integer, then a is the nth root of b. Okay? But we have to make the distinction if n is odd and if n is even. So if n is odd, we are taking an odd root, like a cube root or a fifth root. Okay? There is one real nth root, and we denote it like this. Okay? The nth root of b. So odd powers and roots are pretty easy. All right? We start out with a positive number, we take an odd root of it, we get a positive number out. If we start out with a negative number and take an odd root, we get a negative answer out. We just get one number out. Okay? If n is even, then we have to be more careful. Think back to last semester. What happened when you took the square root of a negative number? We ended up with what kind of answers? Imaginary, right? We got imaginary answers. In this chapter, we are focusing on real roots. Okay? So, if b is a negative number, and we're asking you to take an even root of it, you're going to say there's no real roots. Okay? There are imaginary ones, but there's no real ones. If we are taking an even root of a positive number, we are actually going to get two answers out. Why do we get two? We have that plus and minus. Okay? The positive root is called the principal root. We don't usually put the plus sign in front. All right? When there's no symbol there, it's implying the positive one. The opposite is the other root. We'd have a negative sign in front. Okay? So, odd roots, we get one answer out. Positive, negative, depends on what you started with. Okay? Even roots, we can get two answers out if we're starting with a positive number. We're going to get no real ones if we start with a negative number. The other piece, the only nth root of 0 is 0. You would never write plus minus 0. Okay? Now, another picky detail. If I asked you to solve a squared equals 36, what would you do to solve it? You'd have to take the square root of both sides, okay? In doing that, we always put the plus minus in there. So you would give me answers of positive and negative 6, okay? That is different from me saying this. If I give you a square root symbol with a 36 inside, I am implying that I want the positive root or the principal root. There's no symbol in front. You don't put a plus minus symbol in there if the square root symbol is already drawn in. Okay? The answer to this is just 6. the answer to this would be -6. You see the difference? And again, if there's a plus minus in front, then you'd put a plus minus in your answer. So if the root symbol is already given to you in the problem, put down the answer they're asking for. Are they asking for the principal positive one or the other negative one? If you have to physically draw that square root in as a step to solving, or if they just in words said find the square root, and you actually draw the symbol in, then you have to put down both answers. Okay? All right. Couple terms that we need to make sure you're familiar with. Our square root symbol is referred to as a radical sign. The whole expression is often referred to as a radical. Simplify the radical. The number in front that you see is the index. That tells you what kind of root you're taking. If you are taking a square root, because we use square roots so often, we skip writing the little 2 in there. All right, it's just kind of implied that you're doing a square root. You can certainly write the little 2 in there if you want. It's not required. But if you are taking a cube root, you have to have that 3 there. Without the 3, you're not taking a cube root. You're taking a square root. Okay? So it's important to make sure you bring that index down in your answer, not just the radical symbol itself. Okay? The piece inside the radical symbol is called the radicand. So we're going to be looking at radicands today. Some are just regular numbers, some are variables. We'll look at both. So our first example here, it says, what are the real cube roots? So again, they haven't put any kind of symbol in there for me. They've just stated in words. They're asking me to find real cube roots. How many answers do we get out when we're taking an odd root? We get 1 answer, right? No plus minus is needed in front of it. We're taking an odd root. So we have 3 of them here. We're doing the cube root. How would I read that number? 0.008. If I were to read it in terms of its place value, what would I say? 8 thousandths? So let's say you're trying to find a root of a decimal like this and you don't have a calculator handy. We can think of it in its fraction form. When you take the root, any kind of root, of a fraction, you just take the root of both the numerator and denominator. You can separate them. All right, so this becomes the cube root of 8, which is 2, and the cube root of 1,000, which is 10. So we get 2/10. Now, since the original question was a decimal, I'm going to go ahead and give the answer as a decimal. 2/10 would be 0.2. Okay? Our second example, they're asking me to take the cube root of -1,000. We already said the cube root of 1,000 is, what did we have? 10. So the cube root of -1,000 would be -10. All right. And the cube root of 1/27. Again, split it up. The cube root of 1 is 1. The cube root of 27 is 3. Okay? The next set asks us to find real 4th roots. Okay? Little bells should be going off in your brain right now because this is one of those picky little details. We are taking an even root. What do we have to remember? The plus and minus signs. Okay? So we want plus minus the 4th root of 1. We want plus minus the 4th root of -0.0001, and we want plus minus the 4th root of 16/81. Okay, so looking at the first one, what is the 4th root of 1? It is 1, but my answer is going to be positive and -1, right? Both roots. The next one, I'm taking an even root of a negative number. What happens? There's no solution, right? There's no real answers to this. There's imaginary ones. We don't want those. We want the real ones. Okay? They just asked for real ones. So I would say no real roots. Last one, we're doing a fraction. What's the fourth root of 16? And the fourth root of 81? 3. Is my answer 2/3? What should it be? Yes. We need to bring down that plus minus sign. Okay? All right. Let's have you talk at your tables. It says, according to the fundamental theorem of algebra, x to the fourth minus 1 equals 0 has how many roots? And then how many of those are real? Okay, I'm going to pause the recording. Talk at your tables. Think back to last semester. How many roots should that have? All right, we're looking at solving x to the fourth minus 1 equals 0. How many total roots should it have? It should have 4. We know that based on the power. Okay, we should have a total of 4 roots. We usually find those by factoring. All right, think back to last semester. How do we factor x to the fourth minus 1? X squareds in each. Okay, we need two numbers that multiply to be -1 and add up to 0. What do we have? Okay. Can either of those factors be factored more? Okay, x squared minus 1, that is a difference of squares. It factors into what? Okay, can we factor x squared plus 1? Not if you're limited to real numbers. It can be factored with imaginary numbers, but it can't be factored with real numbers. So I'm going to leave it like this. Okay, what is my solution to those? -1 and +1? Okay, those are my two real ones, right? The other piece gives me what kind of solutions? It gives me imaginary. If we tried to solve it, we'd have to subtract the 1 over. We'd then be square rooting. And when you square root a negative, you get imaginary answers, right? So plus and minus I would be the two imaginary pieces. Again, our focus in this chapter is on the real parts. Okay? All right. I want you to compare these questions to the ones we did on the previous slide. What's the difference? And again, it's one of those picky little details that you got to think about. In the first questions we did, look at the directions. The directions in words said, find the cube roots, find the fourth roots, right? You had to physically draw in that radical symbol. So then we had to think about, do I need the plus minus in front and all of that? Okay? In these examples, the radical symbol's already drawn in. So we're going to give the answer they're asking for. Okay? So for the first one, what is the cube root of -8? Analyze it. We're doing a cube root, odd roots. Do we have to worry about the signs? No. It says take the cube root of -8. We're going to get what kind of answer? We're going to get a negative answer. What's the cube root of +8? 2. So the cube root of -8 would be -2. Okay? The square root of 4 1/100ths is what? Again, think of it in fraction form if that helps you. The square root of 4 is 2, and the square root of 100 is 10, so our decimal would be 0.2. Okay? Notice I did not put plus minus in front of that. The square root was already drawn in. They were asking for the principal or positive root. For part C, it says take the fourth root of -1. Can we do that? Even roots of negatives result in imaginary things, yes? All right, so we would say no real roots. How is part D different? What do you see in there that we didn't have in the other ones? Yeah, we have a power inside the radical symbol. I want you to think of working from inside the radical symbol out. So what happens when you take -2 and square it? We get a positive 4. So it's really saying, what is the square root of 4? And your answer, notice, is just a positive 2. Okay? Many students look at something like this and say, my index is 2, my power is 2. They're just going to undo each other. All right, so the common mistake is for students to put a -2 down as the answer. You have to think through the process. By squaring it right here, we lose that negative sign. Okay? All right, go ahead and try the next ones. And then check in with the people at your table. All right, what is the cube root of -27? -3, good. Fourth root of -81. Good. How about the square root of -7 to the second power? Good. And last one, square root of -49? Okay. So the one that we just talked about, where we said the square root of -7 squared, you said that came out as a positive 7. When we're dealing with just regular numbers, it's easy to figure that out. It's easy to write a positive 7. The problem comes in when we have variables. Because a variable can be positive or negative. We don't know. And we have to ensure that it's going to come out positive. Okay? So, next picky detail. Normally, an nth root of something raised to an nth power, we think of just canceling each other out. Okay? And that is true if we're taking an odd root. So if I said take the cube root of -2 cubed, what would your answer be? -2. I take -2 and cube it, I get -8. And earlier we did the cube root of -8, and we said we come up with -2. So something like this, when it's an odd root, if those match, they cancel each other out. We're back to what we started with, in this case, a -2. If it's an even root, it doesn't work that way, right? We just talked about it with this one. So if you are taking an even root, we have to include absolute value bars around those variables to make sure that they're going to come out positive. Okay? So this picky detail, we have you remember as even, even, odd. Okay? Say that out loud. Even, even, odd. If you have even, even, odd, you need absolute value bars. Okay? Write that down. Even, even, odd. You are going to need absolute value bars. Now, what does that mean? Even, even, odd. It means if you start with an even root and you have a variable to an even power, okay, even, even, and it comes out with an odd power, that's when you need the absolute value bars around it. Okay? So, for example, if I said take the fourth root of x to the 12th, we have an even root and we have an even power. what do we get for an answer? Do you know how to simplify this? It is x to the third. We basically are just taking 12 divided by 4. The way I think of it is we have 12 x's being multiplied together. We are taking them in groups of 4. So if you have 12 x's and you want to group them into 4s, you get 3 groups. Does that make sense? Okay. We started out with an even root, we had an even power, and we're ending up with an odd power. Do I need bars? Absolute value bars. Yes. Okay. All right. Let's look at a couple examples. In this first one, we have a coefficient of 16 and then an x to the 8th. We can split that up. What's the square root of 16? 4. Okay. What is the square root of x to the 8th? Again, think in terms of that little index. We're taking groups of 2. If we have 8 things, how many groups of 2 can we make? We can make 4. So we'd have x to the 4th power. Will x to the 4th ever be negative? It doesn't matter what x is. It can be positive or negative number. When I raise it to a 4th power, it's going to end up being positive. Since that 4th power is going to make it positive anyway, I don't need the absolute value bars. This was an even situation. I don't need them then. Okay. Our second question, we're taking a cube root. Do we need to worry about absolute value when we're doing an odd root? No. All those picky details you have to remember are all the even root stuff. Okay. So cube root of a to the 6th. If you have 6 a's, how many groups can you make of 3? We can make 2 groups of 3. So this is going to come out as a to the 2nd. For the b's, we had 9 of them. We want groups of 3. How many groups can we make? 3. Okay. Again, we're just dividing. 9 divided by 3. Okay. Next one, 4th root. Do we have to think about absolute value when we're doing a 4th root? Yes, we have to consider it. Okay, what's the 4th root of x to the 8th? We have 8 objects. We're taking them in groups of 4. We can make 2 groups. So we have x squared. How about for the y's? We have 12 of them. We want groups of 4. We can make 3 groups. Plus 2. Will x squared ever be negative? Then we don't have to think about bars around that. Would y to the 3rd ever come out negative? It could. If y is a negative number, cubing it's going to keep it negative. So that's where we need the bars. Okay? So we had even, odd. We need them around it. Okay? Just make your absolute value bars long enough that we can tell they're not just a 1. Okay? All right, I'm going to pause the recording. I want you guys at your tables to try the next 3. All right, first one, square root of 81. 9, square root of x to the 4th. X squared, do we need absolute value bars? No. Okay, next one, cube root of a to the 12th. A to the 4th and b to the 5th. Any bars around those? Why not? Odd power, or odd root, yep. And then this next one, the 4th root of x to the 12th would be x to the 3rd. The 4th root of y to the 16th is y to the 4th. Do I need absolute value bars? Where? Around the x to the 3rd, okay? Even, odd. Okay? I do want you to make the distinction in this one. The x is the only part that needed the absolute value bars. That should be put alone in the absolute value symbol. Okay? If both x and y had needed them, then you could just do one set of absolute value bars around the whole thing. Okay? All right. Our last question. It says some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting the scores is A equals 10 times the square root of R, where A is the adjusted score and R is the raw score or the original score. If raw scores on one test range from 36 to 90, what are the adjusted scores? So what we're going to do is we're going to replace 36 for the R in that formula, and we're going to replace the R with a 90. And we're going to see what those new adjusted scores are. The first one we should be able to do without any calculator. Square root of 36 is 6. 6 times 10. So what this means is that somebody that originally had a 36 on their test now gets a 60. Okay? The square root of 90 is not perfect. We should be able to estimate, what would you say it's going to be close to? Think of the perfect squares around it. What's the square root of 81? 9. And the square root of 100 is 10. Square root of 90 is somewhere between 81 and 100, right? So my value is going to be somewhere between 9 and 10? Okay. And it's close to halfway in between. So we could estimate somewhere around 9.5. All right. Go ahead and grab your calculators. Take 10 times the square root of 90. What do we end up with? 94.87. So we were pretty close with our 9.5 times the 10 would be 95. We're going to just round this to about 95. So we're going to say our adjusted scores would range from 60 to 95. Okay, just an example of where you might see a radical symbol in a formula. All right, so quick review. We were looking at finding nth roots. Are we able to do that? Lots of picky details, pay attention to them. Okay? If you have to physically write that even root symbol in, make sure you put the plus minus in front of it. Okay? The other one, watch for when you need absolute values. So today's assignment is from your book. Tomorrow will be a worksheet as well as the formative quiz. So make sure you have charged Chromebooks. If you know you're going to be gone tomorrow, come talk to me so I can get you the worksheet.